This is AZR312, Securing Cloud Applications with Windows Azure Active Directory. My name's Chris Padgett. I'm a development consultant with Cloud Solutions in Melbourne. I also co-host the Melbourne Windows Azure user group. So if you're in town, please come along to the next meeting. What I'll be doing over the next 60 or 65 minutes or so, leading up to the first coffee break, which is important for everyone, is exploring Windows Azure Active Directory in the context of developing and integrating applications with it, whether they be cloud applications or SaaS applications. And I'll be quite liberal when I discuss cloud applications. They can be either applications running in the cloud or perhaps line of business applications running on premises, so just keep that in mind. So I'll introduce the new challenges with regards to identity and access management in the cloud and how Windows Azure can help meet some of those challenges. I'll introduce how you can administer your own Windows Azure Active Directory tenant, a directory service running in the cloud, and how you can integrate your applications with it. And then I'll walk through three key scenarios. First one being how you can secure your web applications with Windows Azure AD for single sign-on, what's otherwise known as passive authentication. How you can integrate your cloud applications with Windows Azure AD Graph in order to query information about users, groups, roles, contacts at runtime. And finally, how to secure your web services using a preview feature that's known as active authentication. And I'll just wrap up with introduce a few other preview features that become available in the last few weeks. Okay, identity in the cloud and how Windows Azure helps us with this. So I've been building new applications for and migrating existing applications to Windows Azure for a few years, especially for large enterprise customers. And invariably, the same questions are raised when we begin to discuss security and how to secure those cloud applications. Customers ask, how do we implement single sign-on across our new applications running in the cloud? How do we implement single sign-on across maybe SaaS applications we're buying in the cloud, such as Office 365, Windows, Intune, and others? More importantly, how we can integrate those applications and services with our on-premises directory. So obviously for a large corporate organisation, they generally have a large investment in an Active Directory environment. They want to integrate that with their cloud applications and SaaS services. Further to that, when we build these new applications and migrate existing applications, how can we query information about users, roles, groups, and other directory objects at runtime in order to control access to an application or a SaaS service that's running in the cloud? And Windows Azure provides us a few options. As a good consultant, my answer is always, it depends. But there are three options available to us. The first one is we can host Windows Server Active Directory on Windows Azure infrastructure services. I'll talk about that in a sec. We can use Windows Azure AD, which of course is what we're exploring today. Or if we're willing to outsource the management of our identities to third parties, such as Facebook, Google, Microsoft, and others, then we can use Windows Azure AD Access Control, which again I'll just touch on as we pass through each of these options. In terms of hosting Windows Server AD, we can host it in Windows Azure Virtual Machine, so as an infrastructure service. Connect that Windows Server AD with perhaps a range of cloud services or other virtual machines that are running in the cloud using a virtual network, a VNet. And then further integrate that virtual network running in the cloud with our on-premises virtual network using Windows Azure Virtual Networks, a VPN. Now, I'm not going to talk about the details of this, probably other sessions that talk about this in detail, but that is an option that is available to you. What that allows you to do is replicate your on-premises Active Directory environment with that you've established in the cloud on Windows Azure. You can do that at a forest level, a domain level, and so on. As an application developer, this is great because, especially if I'm migrating an existing application that demands or requires Windows integrated authentication, this is the one and only option that's available to me as part of that migration. Using Windows Azure AD is a bit different. So Windows Azure AD is a cloud-based directory service that we can use when we want to integrate our cloud applications and SaaS applications in order to authenticate users, in some cases authorize them as well. As you can see there below the second point, there are a number of SaaS applications that can be integrated with Windows Azure AD. They're not only Microsoft SaaS services, but also third-party ones, such as Google Apps, Salesforce, and others. If you choose Windows Azure AD as your option, identity management option in the cloud, it demands federated authentication. So from an application development point of view, That may mean you have to change the architecture application from one that requires Windows integrated authentication to one that is claims-based. Microsoft, of course, provide a great framework that allows us to build claim-based applications known as Windows Identity Foundation. Further to a directory service that's running in the cloud, Windows UAD allows us to integrate our on-premises AD with that cloud directory service so that we can synchronize information from our on-premises environment to our directory service running in the cloud, and further that federate authentication from the cloud directory service to our on-premises one, such that users assign themselves into our new applications using their corporate credentials that we continue to manage on-premises. And that really goes to the supporting a single sign-on experience for users. Insofar as if a cloud application is running in the cloud that's integrated with our Windows UAD, that is further federating authentication with our on-premises AD, and a user is signing themselves in using a domain joined computer, they effectively don't have to sign themselves in at all because they've signed into that on-premises environment. And that is the single sign-on experience for them. Kind of make sense? Yep. That's pretty cool. The last option is to use Windows UAD access control. So the previous two options, as a user of Windows Server AD or Windows UAD, you manage the credentials for your users, the accounts for your users. With Windows UAD access control, you can outsource the management of those identities to a third party. And there's a range of them there below the third bullet. Facebook, Google, Microsoft, other web identity providers. Windows Azure AD access control has been around for a little while. It's been around longer than Windows Azure AD directory itself, and is quite well established, especially for internet-style applications. Probably not so relevant for intranet-style line of business applications. So we'll leave the first and third option behind and explore a little deeper the second option, the use of Windows Azure AD as a way of securing our cloud applications and SaaS services. The benefits of using Windows Azure AD, as I kind of alluded to a bit earlier, is that it can become an identity hub for you in the cloud. Whether you're federating and synchronizing with your on-premises Active Directory or not, it's a great way to manage accounts and the identities of users in the cloud. If you are integrating your on-premises Active Directory with Windows Azure AD, of course, you're allowing your users a single sign-on experience, which as a corporate user, that's quite important, rather than having to remember a range of different passwords, which is often the case today. There's also some new preview features that have been released in the last month or so that provide better insight in how users are signing themselves in through these, and that information is surfaced through access reports, and also for applications that require a second factor of authentication. Microsoft now provide a multi-factor authentication SDK and service that runs as part of Windows Azure AD, which I'll demonstrate a bit later. So that's all the intro stuff. Three options. I've chosen Windows Azure AD to explore today. Now I'll just kind of walk you through how you administer your directory service in the cloud, and walk through those key scenarios with you. So a tenant. A Windows Azure Active Directory is something you can create using the Windows Azure Management Portal or PowerShell commandlets. And once you create one, and only one for all your Windows Azure subscriptions, effectively you end up with a topology that's similar to what's shown on the slide. And this compares and contrasts the cloud topology with the on-premises one. As you can see, they're quite almost the same, well, similar. Albeit that the platforms and technologies are slightly different. So we're on premises. We may have a range of products and applications that are integrated with Windows Server AD for authentication, and on-premises apps that may be using LDAP queries to read information about users at runtime. We have a similar set of features or platforms and technologies in the cloud. Platforms such as Exchange Online, SharePoint Online, and your own cloud applications can integrate with a single Windows Azure AD instance, if you will. And your cloud applications can use what's known as the Graph API, which is similar in theory or concept to LDAP API to query information about users at runtime, maybe to control access to certain areas of your applications. So it's quite a similar model. It's not a major shift to go from an on-premises kind of mindset to a cloud one. Just before I talk about how you can administer a tenant and what you can administer, let's quickly flick to Windows Azure Management Portal. said. Here we go. This is the Cloud Solutions subscription. Well, there's multiple subscriptions under this single account, and I've created in advance of today's session a Windows Azure AD tenant. All I had to do that was scroll down to the Active Directory tab, and before I had a tenant, the one and only tenant for this subscription or set of subscriptions, it asked or invited me to create one. It's as simple as following a link, entering a tenant name, which I've called, it's not listed there, Cloud Test, and within minutes it created a directory service for me. Okay, it's quite a simple process. Easier than installing virtual machines and those types of things anyway. Once I click into my directory, my Cloud Solutions Windows Azure AD tenant, I'm presented with a dashboard, a list of users that I can manage, a list of applications that I can integrate, and we'll explore this a little more later, a list of domains that are available or I've either been defaulted for me or I've added myself. When I created the Windows Azure AD tenant for the first time, Microsoft assigned me a default domain called cloudtest.onmicrosoft.com. I then later added a custom domain that allows me to integrate my on-premises directory with this Windows Azure AD tenant to support synchronization and federation scenarios. And the final tab, directory integration, is where I configure my Windows Azure AD tenant for integration with my on-premises AD. So it's quite a simple interface, easy to use as a developer. If you maybe have a dev test subscription, you can provision this within minutes. In terms of what I can do, in terms of managing that tenant, I can add users, I can add groups, I can add users to groups and all those types of things. As I mentioned, I can manage domains, add my own custom domains that I might want to expose or present to my end users. I can integrate, as I mentioned, my on-premises Active Directory for synchronization and federation scenarios. I can add or register applications with my Windows Azure AD tenant to allow them to be configured for single sign-on and read and write directory data scenarios, which I'll explore in one of the key scenarios a bit later. And one of the new features are around application access enhancements, which I'll briefly mention in the previous slide a bit later. So there's quite a lot I can do with quite a lot of different tools, depending on how the Windows Azure AD tenant was provisioned in the first instance. What I did was to sign into the Windows Azure Management Portal and create a new tenant from it. And so I continue to use the Windows Azure Management Portal to manage that particular tenant. Or if I was a command line user, which I am, I can use a rich set of PowerShell commands to administer that tenant as well. In fact, the PowerShell commands are a bit richer than the current management portal. If, however, you're an existing customer of Office 365 or Windows Intune, you already have a Windows Azure AD tenant whether you know it or not. So you can use those account portals to manage that tenant and in fact integrate that tenant or associate that same tenant with your Windows Azure subscriptions as well, albeit it's a bit of a convoluted process at the moment. So really just hopefully provides a high-level overview of what you can do within your tenant and the tools that you can use to do that. I perhaps should have titled this slide Directory Integration because this starts to explore what it means to integrate an on-premises directory with a Windows Azure AD tenant. There's two parts to directory integration. There's one part synchronization and one part federation or single sign-on, if you will. Synchronization kind of comes in two flavors. You have to, if you want to integrate an on-premises AD with your Windows Azure AD tenant and make all those directory objects available to your cloud applications or SaaS services, you have to synchronize your on-premises AD with your Windows Azure AD. It's quite an easy process. I've asked one of my IT pros at work to create this for me. I've got a quick demonstration of it in a minute. But effectively, it's 3 VMs running either in the cloud or perhaps on premises, your domain controller, a directory sync machine, and a web application proxy. The directory sync machine is running a directory sync tool, a Windows service, that synchronizes all the on-premises directory objects, users, groups, contacts, and so on, with the Windows Azure AD directory service. You can configure it to run as often or not as often as you like. By default, I think it's every 10 minutes. So as users are added to your on-premises AD, within the next 10 minutes they're synced to your Windows UAD and available to your cloud applications and SaaS services. It just chugs away in the background. Over and above that, you can also synchronize passwords from your on-premises accounts to your cloud directory accounts. And this really determines, whether you choose this option or not, really determines the sign-on experience for your end users when they launch your cloud applications or SaaS services. Should just note the password synchronization is not synchronizing the plain text password, it's the hash of that password. So they're the two synchronization steps, if you will, as part of setting up a directory integration with Windows Azure AD. In terms of the sign-on experience, if you're not synchronizing passwords, but you have enabled federation with your on-premises AD, I'm kind of assuming you know what that means, by the way, users will be signing themselves into your on-premises environment using their on-premise account, their corporate account. You continue to manage the username and passwords for those. They don't go, they're not synchronized to Windows Azure AD. If, however, you are synchronizing passwords using that second option, then users can sign themselves into your cloud applications and SaaS services using a copy of their password in Windows Azure AD. You don't necessarily have to set up and configure and activate all the federation infrastructure that's required to support that. Okay, so you've got a couple of options there. Password synchronization just became available in the last couple of weeks if you want to check up on that. A quick demonstration of that. Switch back to I have an application that's running in the cloud called MVC Music Store. It's a sample ASP.NET MVC application. It's a little old now, it's 2 or 3 years old. But I've already configured this to federate authentication with my on-premises Active Directory, so that as a corporate user, I can sign into this cloud application using my corporate credentials. And now I can demonstrate that. This is not a line of business app, by the way, of course, but it's a good demonstration piece. When I add an album to my shopping cart and want to check my cart out, I'm by default presented with a Windows Azure login page. If I had a Windows Azure account that wasn't synchronized with an on-premises account, I would sign myself in here, username and password. If, however, I have an on-premises account, which is this username here, Windows Azure AD login page will redirect me to my on-premises login page. It looks a bit similar in this new version of this is AFS, but this is an on-premises web application proxy asking me to log into on-premises environment using my corporate credentials. I can do that. He said. Oh. That's not working. Bummer. Yeah. If I add into the right password, which I'm pretty sure it is, it would redirect me back to my cloud application. I'll be signed in. My cloud application would then know that I am chris.padgett at teched.cloud.com.au, and I can then continue to access that application. That's the federation part. That's the single sign-on experience that is usually a little better than that. If I switch back to my desktop and open my domain controller, which is a little hard to see, but this is Active Directory users' computers on my domain controller. I can right-click on the users folder and add a new user called John Smith. That's why my password was wrong. I had caps lock on. So I'll go back to that in a sec. John Smith. So I'm just adding a new user, setting a password. Finish that. John's been added. And if I now switch to the directory synchronization virtual machine, this is the one that's monitoring changes to my on-premises Active Directory and will push them or synchronize them to my Windows Azure AD. And there's a directory synchronization PowerShell command that I can run called start online coexistence sync that forces an on-demand synchronization. Otherwise, there's a Windows service that's running in the background that will sync within the next 10 minutes. If I now switch back to my Active Directory, Windows Azure Active Directory in the cloud, and click the Users button, within a few moments, if that directory synchronization has been successful. That user has been synchronized with my Windows Azure AD directory. Okay.
That's group memberships as well.
Yes, so I can add groups, I can add contact information. There's maybe half a dozen objects that have to be synchronized. All those are synchronized on that particular frequency. So this is just to reiterate what's happening here. I've added some information or directory objects in my on-premises Active Directory. I can remove them as well, and those deletes are synchronized as well. I'll now have a copy of that information in my Windows Azure AD that I can then query, and I'll demonstrate this a bit later, from my cloud application, my MVC Music Store application. If I just go back to the list of users, what we can see on the right-hand side here is that there's a mix of different accounts within this single Windows Azure AD tenant. There's a couple of system accounts, which we won't worry too much about, but there's the administrator account for this particular Windows Azure AD tenant. There are two Chris Paget's, one that is being managed wholly within this Windows Azure AD tenant, so it's not synchronized at all with my on-premises AD, and there is the Chris Paget that is synchronized with my on-premises AD. Difference between a Windows Azure Active Directory account and a local Active Directory account or on-premises one. And as we saw, John Smith is the one that was synchronized in the last few minutes. So if I disable or turn off caps lock this time and do it properly, I can buy the Nirvana album again, add it to a cart, check the cart out. I'll enter John Smith, in fact. Let's see if this works. John Smith signs himself in using his fully qualified domain name. Again, Windows Azure Active Directory realises that John Smith is a local Active Directory account, not a Windows Azure Active Directory account. I'm presented with my on-premises login page. I enter the case-sensitive password. I'm signed in. I'll return to my application. In fact, I'm showing a little bit of information about John Smith that I've read from the Windows Azure AD, the synchronized copy of that account. That kind of makes sense? Yep. I could also sign in using Windows Azure AD accounts, so I'm not bounced to an on-premises login page, because that doesn't make sense in that particular scenario. So there's a lot more to configuring directory integration than that. Hopefully that just gives you a bit of a taste of what you can do with it. So that's tenant administration. The next topic is application integration. So you're building a new cloud application, maybe migrating an existing one. You want to make use of Windows Azure AD, whether it's integrated with an on-premises AD or not. How do you begin to integrate your applications with Windows Azure AD for authentication purposes? And it's a pretty simple process, and I'll walk you through this in a moment. You must add or register your application to or with Windows Azure AD in order to integrate it with your Windows Azure AD tenant. Applications can be web apps, they can be web APIs or web services. As a preview feature, they can also be native client applications, so perhaps a Windows Store application that you're developing. When you add an application or register it with Windows Azure AD, what is happening is that Windows Azure AD is creating what's known as a service principal account that represents your application. It's synonymous with creating a user principal, a user account. It's just in this case the account represents the application, not a user. And that's important because not only does it enable the application to authenticate its users against that particular Windows Azure AD tenant, but we can assign an access level to that application depending on its requirements to either support single sign-on, which is the default access level, or maybe read and write directory data. Okay? This is quite a simple process. You can manage all this using the Windows Azure Management Portal. In fact, I'll demonstrate that now. Okay, so what I've created is just a basic Visual Studio solution. I've added an ASP.NET MVC 4 web application project to it, and I've changed the target framework from 4.0 to 4.5. I've also added a Windows Azure Cloud Service project to this solution, and associated the MVC for web application as a web role as part of that cloud project. I've also configured that web role to only support HTTPS endpoints, not HTTP. It's quite important for what's quite highly recommended when you're enabling a single sign-on scenario. That's all I've done to set that up. The next thing I want to do is register my MVC application, web application with Windows Azure AD. To do that, I go to the Management portal, click the Applications tab. I have a few existing applications. I want to add a new one that my organisation is developing. I provide a friendly name for it, MVC application, I think it's called 3. Indicate that it's a web application. I then have to specify a URL at which my application is being hosted. I'm running it from localhost. Once you deploy, which obviously means the URL is localhost. Once you deploy this to the cloud, the application URL might be our .cloudapp.net endpoint. I'm going to specify HTTPS localhost port 444, which is running on HTTPS. And I also have to specify a unique identifier URI for this application. That's, we'll use it a little bit later in one of the other examples. It's important that this identifier doesn't have to be a URL. A URI is fine. What am I going to call this? MVC application 3 local, something that I'll remember a bit later. Actually, I've just got to put trailing slash on there. And they're kind of the attributes, the coordinates, so to speak, that are required to register an application: a name, a URL, and an ID URI. I'm then asked what access level is required to run this or integrate this application with Windows Azure AD. This particular scenario, I'm just going to choose or leave the default, which is to support single sign-on. Click OK. And within a few moments, my application is being added to Windows Azure AD. I'm presented with this dashboard page. From this dashboard page, there's a few buttons I can follow to view the endpoints to help me configure my application to integrate with Windows Azure AD. We'll use one of these endpoints in a moment. I can upload a logo, and I'll describe why this is important in a few more slides. And if I want to, close that. If I want to change the access level that's required by this application, maybe from single sign-on to single sign-on plus read directory data, I can do that in here as well. The one thing I want to do next is I want to configure my web application, my local host application, so that it can federate authentication or single sign-on with this Windows Azure AD, i.e. when the user opens the application, I'm going to ask them to log themselves in using an account that's either managed by Windows Azure AD or maybe one that's been integrated from on-premises AD. To do that, all I have to do is copy this particular URL here, which is a URL to the federation metadata that's required to configure my application. So I've done that, switch back to my solution, right-click on my MVC web application project, and choose this Visual Studio add-in, Identity and Access, which is built by the Windows Azure AD team. This is a simple wizard that allows me to select where my users are from, so to speak. I'm selecting a business identity provider, which is what Windows Azure Active Directory is. I paste in that URL that I copied from the management portal, and I enter the same name, application ID URI that I entered a bit earlier, which I hope was that, and click the OK button. What that Identity and Access tool is doing is downloading that federation metadata document from my Windows Azure AD tenant and configuring my application for single sign-on. If I open up the application, what's essentially done in the web config, I'll scroll down a little bit. This and that configuration section are required by Windows Identity Foundation. And the Identity and Access tool has configured those sections for me to effectively, when I press F5, I'm integrated with the Windows AD tenant and I can single sign users in. Although I do have to change one setting in system.web, which is this, to allow a security token to be returned to my application once the user signs in. So that was pretty simple. That's a 5-minute exercise for an application developer. I'm just waiting for the application to compile and run. Once that's done, you generally don't have to return to it. It's a one-time setup, a one-time configuration. Okay, so it's built. The Windows Azure Cloud project is my startup project, so it's starting the compute emulator up to host my MVC web application. Everything runs a bit slow when you're attempting to demonstrate it on stage. Okay, here we come. I'm just going to choose localhost 444, which is what I told Windows Azure AD is where my application is being hosted. I have a self-signed certificate for my HPS endpoint, which I'm going to ignore. Now, this particular application denies access to all users. Okay, so unlike my MVC application where I had a kind of a guest page or anonymous page, this MVC application denies all anonymous users. So it's kind of blanket authentication. As soon as I access the application, I'm asked to sign in. So I can sign in using an account in my Windows that's managed by my Windows Azure AD tenant. Caps lock is off. I'm signed in. Windows Azure AD has validated me. I return to my application and I can present my username or user principal name at least to the end user. That's all that's required to integrate your applications with a Windows Azure AD tenant.
I didn't notice. Did you associate users to apps, or is it anybody in your tenant has access to them?
Anyone in the tenant, and when we talk about graph, we can talk about how we can control access by those users to your app. Yep. What's even nicer is I can close all these browsers, open up a new one, run the same app, accept the security certificate warning, and because my Windows Azure AD tenant is integrated with my on-premises AD, I can also sign in using the teched.cloud.com.au user. Oops. Redirects me to my on-premises login page that's hosted by ADFS. Sign in using my corporate credentials, and I get the same page. So that's pretty cool as an application developer. I think it's pretty cool as an application developer. Cool. That's that. One of the newer features of Windows Azure AD is that you can also enable your applications to be shared with external parties, whether they be your customers, your partners, suppliers, other business trading partners, and all that sort of thing, as long as they have a Windows Azure AD tenant as well, which is free, by the way. I'll demonstrate the work or the page flow around this in a moment. But essentially what it requires is the company administrator, the tenant administrator for the external organisation must grant your application access to their particular Windows Azure AD tenant. Your application can request single sign or read or write directory data. As long as they're happy with that level of access and they grant it, your application can then federate with their users and access their directory to query information about those users and roles and so on. As the provider of the application, what you generally have to do is provide an activation or a sign-up page so that the company administrator for the external organisation can visit your application to sign themselves up for the first time. And what they will see are these two screens here. If they haven't already signed into their own Windows Azure AD tenant, they sign themselves in as the company administrator or the tenant administrator, and then presented with what's known as the consent page. Maybe a little hard to see, but basically grant access ? This is the application that's requesting access to your Windows Azure AD tenant. It's got a name. If we'd uploaded a logo a bit earlier, that would have been shown here. And it also down the left-hand side presents the access level that's required by the application to their directory tenant. All they then have to do is click the green button to grant access to your application, by your application to their directory tenant. And that service principal that I mentioned a bit earlier is also created in their directory tenant. So that allows your application access to their directory tenant with the required access level, the required permissions. Does that kind of make sense? So as an external user, and you providing those external users or external administrators with a sign-up page, it's quite a simple, basic flow to get access, for them to get access to your applications, which is pretty cool. What you can also do, I mentioned just on as last point on the previous slide, is your application can provide a consent return URL to Windows URAD. So once the company administrator for an external organisation has either granted or rejected your app, you can handle particular logic around that by providing a consent return URL. So maybe you want to onboard some information about them, maybe the sign-up date and all that sort of thing. Once they have granted access by your app to their directory tenant, you can do that sort of application logic. It's always also worth mentioning if you're building apps to be shared with more than one external user or organisation, you do have to build, generally speaking, your application be multi-tenanted. There's particular complexities around that, which I'm happy to discuss over coffee a little later. Okay, so that's hopefully given you a kind of a broad brush overview of what a Windows URAD tenant is, how you administer it, what you can administer, kind of the user experience for managing that AD tenant, and as an application developer, what you have to do to get yourself started with Windows URAD in terms of integrating it for single sign-on. Now, I just want to kind of dive into a few key scenarios that I mentioned a bit earlier. First one being how we secure, I've already demonstrated some of this, how we secure our web applications using passive authentication. If it wasn't obvious what was happening a little earlier, this is what is happening at runtime. And we experience this every day when we sign into the management portal or Outlook.com or whatever it may be, where those services are being federated with an identity provider such as Windows URAD. It's a multi-step process when a user has to sign themselves in to access your application. They're attempting to access a protected resource of your application. Maybe the home page, it may be a cart page or whatever it may be. And this flow is what's known as passive authentication. Is required to support single sign-on for browser applications or web applications. What happens is when a user attempts to access your application as an unauthenticated user, and when they're meant to be authenticated, then your application, through its configuration of Windows Identity Foundation, which is that WIF box to the left of the application block, will intercept the unauthenticated user and redirect that user to the Windows URAD tenant that's been associated with your cloud application. And that association is represented by that service principal block in the top right there. So we've already added our application to a Windows Azure AD tenant. Users redirected to that, they sign themselves in to the login page, otherwise known as the security token service. And if that is a valid user, then Windows Azure AD tenant will return a security token, most often formatted as a SAML token. That security token that's issued by Windows URAD tenant indicates that that user has signed in and you can trust me, so to speak. Okay? That orange security token is then posted to your application, and again, WIF will intercept that and validate that incoming token, security token, that it is a trusted token. And if it is, WIF will then issue its own token for the life of the browser session, otherwise known as a session token. So there's one-time exchange of went on the other button. This one-time exchange of this initial security token, which indicates the user has signed themselves in to Windows URAD, and then WIF will then manage the life of that browser session using this green token here that's sent with every request to your application. And that token can contain information, as much information about the signed-in user as you wish. By default, it will contain their username, their first name, and their last name. That's how all this is enabled. When I use that identity and access tool in Visual Studio to demonstrate how to configure an application for single sign-on for the first time, all that configuration enabled that end-to-end flow. Stuff I don't have to worry about, which I'm happy about. Just to take my previous demo a little bit further, I won't use the same solution. This is the solution not that one. Stop this one running. The MVC Music Store application that I browsed to a little earlier is represented by this solution here. It's pretty simple, just an MVC application and a cloud service application. If I just quickly run this. So this is hosted on my local computer emulator, not in the cloud in this instance, so I can demonstrate it. What I just want to walk you through, you've already seen the sign-in process and how I configure or update the web configuration to enable a sign-in scenario. What I just want to quickly show you is how to support a sign-out scenario, a single sign-out scenario. So go to my local host to browse the MVC application. Okay, so this time I've added a sign-in gesture, so to speak, that allows me to sign in as chris.padgett at, so this is my Windows Azure AD account, not my on-premises one. So I'm signed in, the application knows who I am. In a follow-up demo, I'll show you how to get more information about the signed-in user. Now that the user's signed in, I can support them signing out. And what I showed you on the previous slide is kind of what happens in reverse when a user signs out. All those tokens are destroyed. Browsers are redirected from the application through to Windows Azure AD and back. And the user has signed themselves out. If I click that, you can see a little message, sign out in progress. And I'm now signed out. Okay? Unfortunately, I have to write a few lines of code to support that, to implement that. But it's not a stretch. So I just go back to my solution. The sign out link or gesture at the top of the page was an action link to this authentication controller. Get this out of the way. Sign out action. And what these lines of code are doing, firstly, that first line of code is signing the user out of the green security token, that session token the WIF has created for this application session. And then the following lines of code, 5 or 6 lines of code, basically create a sign-out request message that is sent to Windows Azure AD. This is not a WCF message, it's a browser message, so to speak. Okay, so using the configuration that has been set up for me by the Identity and Access tool, I can create a sign-out request message, provide information about the directory service or the issuer of the original security token, which in this case is Windows Azure AD. Indicate or add my tenant ID to that particular sign-out message, so it indicates that my application's the user signing out of my application, out of my Windows Azure AD tenant. Convert that sign-out request message to a URL, basically, and redirect the browser to that URL. And you saw that switch, that's kind of white page that said sign out is in progress. That's what's occurring after that redirection has occurred. Okay? At the end of all that, the user is returned to my home page as an authenticated user again, okay? Which I've allowed access to in this particular MVC application. So with a few lines of configuration, but for the most part you don't have to worry about, and a few lines of code that you can repeat over and over and over, or I can almost, you can support single sign-in and single sign-out whether those users are assigning themselves into a Windows Azure AD tenant account or an on-premises AD account. Works both ways. It's pretty cool. So that's securing web applications. Not a lot of configuration, not a lot of code. A lot of value though. The next scenario is how, just answering your questions a bit earlier, Dean, how can we query more information about the users, the roles and the groups from our applications, where those users, roles and groups are either managed by Windows Azure AD tenant itself or synchronized with that tenant from an on-premises AD environment. To do that, we use what's known as the Windows Azure AD Graph API. It's a REST API. More specifically, it's a no data v3 set of endpoints for accessing information that's managed or synchronized with Windows Azure AD. The Graph API supports a number of, a range of CRUD operations on some key entities, users, roles, groups, and contacts. As I explained a little earlier in the side-by-side slide that had the cloud topology and the on-premises one, this is synonymous with you accessing your own on-premises directory using LDAP. Okay? The concept the same, the protocols and the technology is different, but it's not a large leap. The key thing is that in order for an application, for your application to access information about users, roles, groups, and so on, the application must sign itself in to Windows UAD before it can access the Graph API. So it has to acquire a security token, much like a user does when they're signing themselves into your application, that orange token I showed a bit earlier. In fact, I've demonstrated this over the page. It's a much simpler flow than the passive authentication scenario, but the application that's represented in blue on the left that has been added and associated with a service principal in a Windows UAD tenant. Firstly, posts a request to the security token service, a login service, if you will, as part of that Windows Azure AD tenant, to sign itself in to get a security token, which is represented by this, again, by this orange security token symbol here. The application identifies itself using an ID and effectively a password, a kind of long key. Once the application has acquired that token, it then sends it with each request to the Graph API, which I've shown in green here. I'll show you the kind of the query syntax in a moment, but that's essentially all that's required for your applications to access a Windows Azure AD directory. Just before I move on to a couple of other slides, I mentioned a bit earlier when you add an application to Windows Azure AD tenant, you must specify an access level. Obviously, single sign-on is not sufficient to support this kind of scenario. An application must be registered with either read and write directory data access level. That's represented by this role here. It's assigned a particular role that grants that particular level of access. There's a range of entities and types that you can query. Some pretty well-known ones on the left there, but you can query information about applications that have been added to Windows Azure AD, service principals have been associated with them, so on and so forth. And from the entities on the left, you can then navigate to some types on the right to maybe query what licenses have been assigned to a particular user, whatever your particular scenario might be. So it's quite a rich set of entities and types that you can query and create, update, delete. Here's some common queries in their RESTful syntax. Microsoft provide a free download that is a kind of a managed SDK that wraps these RESTful APIs or RESTful operations. This is just a small list. The MSDN documentation has quite a good, complete reference guide to all the operations or queries you can perform against the Graph API. Just as a bit of a taster, when we want to query information about a particular user, we can list all the users in a directory tenant and maybe page through them. We can find users by their, either by their user principal name, their username, or perhaps attributes about users, such as their surname. We can link or navigate through direct report relationships from one user to another and all those types of things. Okay? So all those directory objects are under management by Windows Azure AD, can be queried. If you are using the REST API, it's quite a simple syntax, right? If you're using the managed SDK, you use a link-like kind of query syntax. Just before I move to a demonstration, Windows Azure AD also, Graph API also supports what are known as differential queries. And this is useful, as kind of highlighted in the final point there. If you may have a scenario where you may want to synchronize some of your application data with some of your directory data. So you can build, for example, maybe a worker role in a cloud service or maybe an on-premises Windows service that executes a differential query every day or every hour, whatever it may be, to access the changes to the directory objects that have occurred since your previous, since the previous day or the previous hour. In order to do that, I don't think there's a managed SDK for this. I'll have to check out. Can't remember. But in terms of the RESTful representation, sorry, that's the wrong button again. In terms of the RESTful representation, it's a pretty simple URL. In this particular case, we're attempting to access the changes for the directory of users. This is the initial query on the left here. On the right here is the same query with a delta link, i.e. a token that was returned with my previous response that I send with my next request. And that token indicates to Windows Azure AD that I want to access the changes since that last request. Those requests or those responses can be rather large. You can page through them and all those sorts of things. But it's quite a useful tool or API for supporting those synchronization scenarios. Just to demonstrate that to you. just run this application, demonstrate what it's about to do. You might have noticed there was an admin link in the top right corner of my MVC Music Store homepage. Obviously, allows administrators access to some of the administrative features of my MVC store. Obviously, I don't want any user to be able to access those particular administration features, right? So I want to put some access control around that. The way I'm going to do that is that when a user signs in, I'm going to query the roles or the groups that user is a member of, and use that group information to control access to that particular area of the application. Just wait for it to start first. Here we go. Actually, I just got to close that because make sure I've got a new session. Okay, so running off localhost. I'm going to attempt to access the admin area. It's a protected area, so I have to sign myself in as an administrator, which I'm going to do now. Administrator at cloudtest.microsoft.com. Enter the password, sign in. Now, one thing I've enabled for this administrator account, given my MVC Music Store is a particularly sensitive application, is a second factor of authentication. I'll show you how to enable this in a moment. I'm hoping I'll receive a phone call if reception is good to my mobile phone. You can see there that now I've identified myself as the administrator account. Microsoft is calling my phone, which they've done. Thank you. Let's hold this up.
Thank you for using Microsoft Sign-In Verification System. Please press the pound key to finish your verification.
If you didn't understand that, they've welcomed me. They asked me to press the hash key on my phone and then the call. That's then relayed back to this sign-in page, which redirects me into my application. They can call me, they can text me. I can download a mobile app to do that second factor authentication. That's pretty cool. To do that, no lines of code. Back in my Windows Azure Active Directory, list of users, administrator, account. Scroll down, I check this box. Pretty simple. The first time I signed myself in as the administrator account, after I enabled this, I was asked how I want to provide the second factor of authentication, call me or whatever it was. I can always change that at a later time as well. That's pretty cool. Anyway, back to this. So I've signed myself in as the administrator account, answered the phone call, I now have access to the administration area. If I sign myself in as Chris Padgett, let's just make sure that this works. Sign out as the administrator. Oops, sorry, just click the admin link again. Sign in as Chris Padgett. You would expect that I can't access that area because I can tell you I'm not part of the administrators group. Okay, cool. Just to show you what I've done there. The first thing I had to do for my application was upgrade its access level from single sign-on to single sign-on with read directory data because I want to read the groups for the signed-in user. At least understand the memberships, the group memberships they have. And when I did that, actually I'll just quickly show that. So this is my local version, the MVC store application. Click the configure tab. So I've upgraded from single sign-on to single sign-on read directory data. And when I did that, I had to create, I was issued, I firstly had to copy this client ID. It's like a username for the application. And create a key, in other words, a password that I have to provide from the application when they signs itself into the Windows Azure AD tenant in order to access the Graph API. There's a couple of administrative tasks I had to do there. Back in my application, I mentioned there's a managed SDK that you can download from, I think it's the MSDN samples site, called the, that's the project name, but the full name is the Windows Azure AD Graph API Helper Library. So you can download that, add that to the solution, and I've added a reference to that managed SDK which is shown this one here, to my MVC application. Having got the client ID, having upgraded the access level for my application in the Windows UAD tenant, I copied the client ID and the new key that I created to my application settings. That's the same, that's the client ID there. That's the key value that I created, because that's going to be used when the application signs itself into Windows Azure AD. One of the other things I had to do, this web app has a reference to a NuGet package, which is the OData library that's provided by Microsoft. I had to upgrade that to 5.3. The Graph API is an OData v3 endpoint, so I had to upgrade that NuGet package. Once I've done all that, I'm ready to write some code. So on the particular store manager or admin controller, I added the authorize attribute and indicated that the signed-in user must be a member of the administrator's role. And that's the role information I'm going to read from the Graph API. In order to do that, I implemented what's known as a custom claims authentication manager. This is part of the Windows Identity Foundation framework or library that allows me to add more information about a user once they've signed themselves in, okay? This information is otherwise known as claims. I won't step through all this code, but essentially what it's doing, this is the line of code, the single line of code that's required to get a security token from Windows Azure AD so that I can then access the Graph API. That was step 1 and 2 in that diagram I showed a bit earlier. In order to get that security token, I specify the tenant in which I'm authenticating myself against, my application username and password in essence. That token is returned, and then I can create a Graph API client, which is represented by the directory data service class, so they can access my particular tenant using the access token that was returned to me from Windows Azure AD. Having done that, I can use link-like syntax to get a user where their particular identifier or UPN matches this value here. You have options for ID or UPN. That is then executed using that single dot or default method there, and I get a user object back. That user object, I basically navigate through all the claims that are returned from there, such as the given name, surname, where they work or live, maybe their mobile phone number, so I can collect all that work info, if you like, about that user. I can present that to them perhaps on their checkout page, for example, to allow an easy way to fill in that particular form. Once I've added all their kind of work info claims, I can then navigate to their member of link, which allows me to access all the groups and roles that they're a member of, that particular signed-in user is a member of. So iterate over all the groups that are returned from that particular Graph API call and add a role claim for each group they're a member of. The administrator user is a member of the administrator's group. I've already configured that within my Windows Azure AD tenant. So there's maybe a dozen, 20 lines of code to kind of set all that up. And this code is executed as soon as the user signed in and control is returned to my application. Okay? So I've augmented what is already known about the user principal with more information that I want to track within or access within my application. To enable the authorize attribute to perform a role-based access check, I then there's multiple ways of doing this, but I implemented a custom ASP.NET roles provider. All I really had to do was implement get roles for user, and all it's basically doing is using the information I know about the current identity. I get all the role claims that I've previously set up in that previous code, return that to the ASP.NET runtime, and it all kind of just works. Okay? So again, this is a few lines of code just to enable those role-based access control checks that you would obviously implement in your line of business applications. Oh, by the way, just to register those two classes, in the web config, that's where I register my custom claims authentication manager with the WIF runtime, WIF runtime. And down in system web is where I clear all the default role providers and register my own custom one. Okay, a couple lines of config. Cool. The last scenario I'll touch on, how much longer have we got? 13 minutes. see if we can race through this, is how to secure web services using what's known as active authentication. So the browser plays a passive role when it's signing users in, or authenticating users against your application. If you have a native client application, such as a Windows Store app, it's got to take more of an active role in signing that user in, okay? It's not told what to do, it has to know what to do, unlike a browser. This is a preview feature. In essence, what it allows us to do is, or allow users to do, is authorize a native client application to call a web service application on behalf of themselves, okay? What the user gets to experience is a login page when they launch that particular client application. They sign themselves in, much like we sign ourselves in using the web browser, using a Windows Azure AD account, or perhaps one that's been synchronized or federated with an on-premises AD. And from then on, that client application can act on behalf of that user when calling web service applications. As I mentioned, this is a preview feature. The developer preview includes a couple of things. As far as the client application is concerned, the developer preview includes what's known as the Windows Azure AD authentication library, which I won't repeat because it's long, the ADL, that provides that sign-in experience for users. It also provides some helper methods for the client application to acquire security tokens and pass those security tokens to the service applications that they wish to call. Okay? So a few helper methods to get you started. On the Windows Azure AD side of things, Microsoft have provided as part of this developer preview an even longer name, an OAuth 2.0 authorization code grant endpoint. Your client, once the user has signed themselves in and a client application wants to access a service application for the first time, the client application must reach out to this particular endpoint to get an access token. Receives an access token with a refresh token. The refresh token allows the client application to have a long-running grant or a long-running session with a service application that it's interacting with. Got another one of these diagrams that kind of demonstrates the end-to-end flow. It's quite similar to the previous diagram. Not many steps, but there is a little bit of setup. So on the left is the native client application. Maybe it's a Windows Store app that's been added, like any other application, to the Windows Azure AD tenant, and a service principal has been associated with it. The green web service application has also been registered with the Windows Azure AD tenant. That's the one that the client application is obviously going to call. And the two things that link these two things together is what's known as an application permission. I'll demonstrate how you can create this in a moment. But that basically allows the client application, or permits the client application to call the service application once the client application has authenticated itself, or the end user has authenticated themselves. Similar to the last scenario, what the client application must do is, once the user has signed themselves in, is post a request to the security token service that's being hosted in the Windows Azure AD tenant in order to acquire a security token, much like the previous scenarios. Once that security token has been, or access token has been acquired, it can be sent or must be sent with all requests to the web service application. The access token that's acquired, as I mentioned on the previous slide, also comes with a refresh token. So if that access token maybe times out after 10 minutes or whatever it may be, it can be automatically refreshed by the client application through the use of the helper methods that are provided as part of the authentication library. In fact, there's quite a cool feature where if your client application can run on multiple device platforms and your account roams with those devices, then once you sign into one platform, effectively you've signed into another one, so that access token can roam with you. As a tenant administrator or a company administrator, what you have to do is, as I said, create a permission that kind of links the client application service principal to the service application service principal. You can't do this in the management portal at the present time, but you can use another online service that's provided by Microsoft as a Windows Azure app called Graph Explorer. And you have to create this permission to basically authorize the client application to call the service application with a particular scope claim, a special claim that indicates that you're authorizing that client application to act on behalf of the end user when calling that service application. Just to quickly show you the Graph Explorer. Here it is. Here's that graphexplorer.cloud. It's not there. graphexplorer.cloudup.net. And I've signed myself in as the administrator of my Windows Azure AD tenant. And by default, it allows me to explore my Windows Azure AD service via the Graph API. So I can click through and list all the users, if I haven't signed out already. There's a list of users. So this is a good debugging tool if you're using the Graph API, by the way. If I want to add an application permission, I click this link at the top. I've already pre-registered both my client application and my service application with the Windows Azure AD. So I can simply select them from these two drop-down lists here. That's my Windows Store app. This is my Cloud Web app. I set the scope claim to user impersonation and I click the Create Permission button and it's done. Okay, so again, another 5-minute exercise for the tenant administrator. There are a few steps on the client side and the service side to, on the one hand, request access tokens, and on the other hand, to validate them. Okay. In the client application, if you've integrated the Windows Azure AD authentication library with it, most of the pain goes away. But the client application nonetheless has to access or request an access token from Windows Azure AD before it calls the service application for the first time. And this is helped in, by one of those ADAL helper classes called Authentication Context, which kind of manages that token for you for the life of that application session. The client application nonetheless has to acquire that token. That's an asynchronous operation. If it's acquiring that token for the first time, it will pop a login page to the end user. It's actually hosted inside a web browser control, and I'll show you that in a minute. So that because the end user has to sign themselves in, okay, before the client application can act on their behalf. Okay, so we'll see that in a moment. Each subsequent time that the client application wants to call a service application, it just resends the access token that's been previously acquired, and we'll refresh it if it has timed out. There's a few more steps on the service side. At the moment, you have to write lines of code to implement each of these steps. I'm hoping that once the developer preview moves beyond preview, that a lot of this will be kind of provided for us. What the service has to do is firstly read the access token that's been sent from the client application. That's sent as part of a HTTP request header, the authorization one. It's known as a bearer token. The service should, depending on requirements, retrieve any up-to-date federation metadata that from the Windows Azure AD directory tenant that it's been associated with. Every 24 hours is probably sufficient. As certificates roll over, we've just got to cover those sorts of scenarios. Once it has the access token, it has the up-to-date federation metadata, it can then validate the access token that has been issued by a trusted identity provider. Again, a few lines of code. If it is a valid access token, the service application then can go and set the identity for the current HTTP context and the current thread. You have to do both. So that information about the end user who has signed themselves in becomes available to that web service. And as a last check, we want to verify the access token contains that special scope claim being set to user impersonation. Okay. Just to quickly walk you through that, because I've only got 5 minutes. I've extended my MVC solution to include a Windows Store application. What I've also done is added a web API controller to my MVC web application that allows a client application to list or get a specific genre. Having added that web API, I then have to implement that server-side validation logic. To do that, I installed a NuGet package called the JSON Web Token Handler, which basically just adds this particular assembly here, system.identitymodel.tokens.jwt. That allows me to validate the access tokens when they're sent from the client application. To implement all that logic, and I won't walk through this in detail, that I showed on the previous slide, those 5 steps, I've implemented what's known as a custom message handler or delegating handler. This allows a web API application to intercept incoming request messages and outgoing response messages before they're passed or returned from a particular web API controller action. It's analogous in a little way to a filter in MVC. So for each request that's being sent from the client application to this web API, if you were to step through this code, I get the access token from the request message. If I can't find it, then I return an unauthorized response message. Before I do that, I download the latest federation metadata from my Windows UAD tenant, if I haven't done so in the last 24 hours. Once I do download that using an XML reader, I basically parse it for issuer, certificate, and other information that it's required to validate an incoming access token. So get the federation metadata, try to get the access token from the HTTP request message, and then for each of the certificates that were downloaded as part of the federation metadata, I attempt to validate the incoming access token. The reason there might be multiple signing certificates is that certificates can roll over, so you can kind of manage that rollover period using, having registered 2 certificates rather than just 1, which means you may have some downtime as you redeploy apps and those sorts of things. This validate token method is part of that JSON web handler, web token handler, a NuGet package that I added to my MVC application. If it is a valid token, that helper method returns a new claims principal for me, which I set to my current principal and my current HTTP context user, and I'm away. I now have access to information about the end user inside my web API. Just to demonstrate that, I'll run my cloud service, which is hosting my MVC project and therefore my web API. Okay, so that's running up, and then I'll start a new instance of my Windows Store app, which isn't fancy, by the way. I'm not a Windows Store app developer. Oh, of course I have to agree to this. I didn't have to do this about an hour ago. While that's running up, I think that's my account. Sorry about this. Thank you. Okay, runs my application. I'll show the code in the client application in a moment. But what is happening is the client application has recognised I'm an unauthenticated user who's attempting to access a service application. As that unauthenticated user, I sign myself in using my cloud test account. It could be an on-premises account. I'll be redirected to my on-premises login page. Sign myself using that account. There's a bit of to and fro. The client application, or Windows Azure AD, has accepted me as a signed-in user. The client application should be spinning something at the moment. What it's doing is acquiring an access token on my behalf and now calling my web API to get a list of genres, which is going to display to the end user. Okay, that was nicely timed. Just to quickly show you the client-side code. And I have both a basic and an advanced version of this, but I'll show you the basic one just for the time being. When the Windows Store application starts itself up, it presents the user with the main view, the list of genres. What we saw was the user has to sign themselves in. And that's done as part of this load genres method. When this main view or main page is constructed, I create a new authentication context. So that kind of bootstraps the authentication flow for me. Okay. When I'm loading the list of genres, the client application acquires an access token from Windows UAD using a couple of parameters. One being the resource, the web API they want to access, as well as the identifier for this particular client application. So those two things are what are linked using that permission object that I showed you a bit earlier in the diagram. Okay? So those two pieces of information are required to acquire an access token. If that has been successful, then the access token itself is returned as part of the authorization result. I can create a new request authentication header, set that as the default request header for all my web API requests, and then go and, via the HTTP client class, go and call my web API with that access a token attached to it. Okay. Again, not not a lot of lines of code. It's a bit messy at the moment, given this is a developer preview, but this will improve over time. The other thing I will mention as I kind of sign things off, because we're all in desperate need of a cup of coffee, is this client ID the MSDN documentation describes how you can acquire this. You have to write a one-time line of code to acquire this particular client ID. And that's what, when you add your client application to Windows Azure AD tenant, you provide that client ID with it. And then connect your client application via that ID through a permission to your service application. And it creates that permission, that link. I have run over time. So thank you for bearing with me. Just quickly before we sign off, a couple of other preview features. Oh, did I press the wrong button? Sorry, there it is. Preview features, access panel. So on one of the earlier slides I mentioned application access is a feature of Windows Azure AD. It's a preview feature. If you have corporate users who've been granted access to a range of your cloud applications or your SaaS services, they can be presented with an access panel. It's quite a nicely tiled page. It's just a launch page for easy access or quick access to all those cloud applications and SaaS services. I also mentioned a bit earlier login reports or access reports. So as a tenant administrator, a company administrator, you can get a bit of insight into how users are signing themselves in and with which devices, so maybe detect some sensitive or suspect behaviour and be alerted on that sort of thing. And I demonstrated multi-factor authentication to you, both as from the administrator's point of view, but from a developer point of view, you can download an SDK that allows you to integrate that MFA feature, those MFA features into your own applications. That's pretty cool stuff. So just to wrap it up, hopefully I kind of been able to introduce you to some, the concepts and the practicalities of using Windows Azure AD and integrating your own applications with it. Windows Azure AD is a free service. It's highly secure, highly scalable, being hosted in the cloud. Over time, you might find that it becomes your identity hub in the cloud. So whether you're integrating with your on-premises directory or not, it's a great way of connecting all your cloud and SaaS applications together using one identity management hub. And further to that, you can then share your applications through that hub with other external parties. Just to close off, you can win yourself a mouse if you submitted an eval for this particular session. So do that, please. Some resources, which you've probably seen already. If you're not already on Windows Azure, you can sign yourself up for a free 90-day trial and get yourself started with what I've shown you today. There are a lot of good online resources, both from an administrator and a developer point of view, to get yourself started with Windows Azure AD. Thank you very much.